Hi students, how are you? Now we will discuss kinematics 1D motion. Particularly, we will learn if your body projected vertically upward, then how kinematics equations will be changed. After that, for the freely falling bodies, how kinematic equations will be changes. We will discuss these things. Later, we will also cover the topics motion parameters in case of 1D motion. Okay, we will start our video. Firstly, vertically projected bodies. Let us imagine the situation. A body is projected vertically upward from the ground surface. Then the body reaches a height h. A body reaches a height h. Initial velocity of a body taken as u. U is the initial velocity and v be the final velocity. In this situation, whenever the body reaches maximum height, its velocity final becomes zero. Velocity is zero. Why? Because after this height, the body do not move further. So that we can make a statement whenever the body reaches maximum height, its velocity should be zero. Understand? So final velocity is zero in this situation. We already discussed if a body moving away from the ground surface, acceleration due to gravity taken as minus g, sign convention, a is equal to minus g. Now if you observe the kinematic equations, I will write kinematic equations here. V is equal to u plus at, s is equals to ut plus half at square, v square minus u square is equal to 2as. Now this equation become under these conditions velocity final 0. So 0 is equal to u minus at. A is acceleration due to gravity g minus g into t will come. And next second equation where s is h. S is nothing but h. So h become ut plus half at square. Initial velocity is there ut, where a is minus g, minus will come half gt square. And for this equation, v square minus u square is equal to 2as. Final velocity, v final velocity 0. So 0 square, no need to write. 0 square minus u square is equal to minus 2gs, where s is h, 2gh. Minus and minus become cancelled. Finally, you can write u square is equal to 2gh. These are the kinematic equations if your body projected vertically upwards. Now we will see the equations for freely falling condition. Freely falling bodies or motion under free fall. Let us imagine the situation. A body is moving downward to a earth surface. After some time, it strikes the ground. So this is the situation. Initially, the body which is at rest. Okay. So in this situation, the initial velocity of your body is taken as 0. Why? Because initially the body which is at rest, initial velocity is 0. Finally, body hits the ground. The body coming from a height h. You can take the replica this situation only. The body reaches height h and again coming downward. While it is coming downward, we will treat the freely falling bodies nothing but motion under free fall. The only force acting on these bodies is nothing but acceleration due to gravity. That's it. Now the body is coming downward towards the earth. So acceleration due to gravity taken as plus g, sign convention. Initial velocity is 0. And finally, it has some velocity. Final velocity is not 0. Should have some velocity. At any instant of position, it should have velocity. Final velocity is there. Now, If I write kinematic equation for this situation, v is equal to u plus at. Final velocity is not 0, but initial velocity is 0. So v is equal to a is g t. V is equal to u 0, initial velocity 0, a is g plus g t, gt. And for second equation where s is h, we can take h as s, displacement, vertical displacement, or height h. H is equal to ut plus, but initial velocity is 0, 0 plus half a is g t square, or simply you can write half gt square. And for this equation, final velocity v square minus initial velocity 0, that equal to 2gh, or v square is equal to 2gh. How to write the kinematic equation like this? If your body is moving under free fall, under gravity, freely falling bodies means the motion under gravity. These are the equations. Now we will discuss 1D motion parameters. Time of ascent can be defined as time taken by a body to reach maximum height. Is nothing but time of ascent. Time taken by a body or particle to reach maximum height is called time of ascent. Let us imagine the situation. A body is projected vertically upward. What happened? It has reaches a height h. Whenever the body reaches maximum height, its final velocity is 0. So height is h, maximum height reached by a body. Time taken to reach maximum height is nothing but time of ascent. We can apply the formula. Initially there is a velocity. Initial velocity is u. U is the initial velocity. Final velocity is 0. You can apply velocity time formula. V is equal to u plus at. But we know sign convention. If your body is moving vertically upward, acceleration due to gravity taken as minus g. Now v is equal to u minus gt. But final velocity 0. Whenever reaches maximum height, final velocity becomes 0. Now minus gt, if I take this side, plus gt, that is u, or t is equal to u by g, where t is known as t suffix a, that is nothing but time of ascent. T suffix a is equal to u by g is the time of ascent formula. Now if you observe, next parameter, maximum height. H suffix mx, maximum height. The vertical displacement covered by a body where its final velocity is 0 is called maximum height. Definition: vertical displacement covered by a body where its final velocity is 0 is called maximum height. You can imagine the same situation. Suppose a body thrown vertically upward, it has reaches maximum height, so that final velocity becomes 0. Suppose it has reached hmx, maximum height. So initial velocity is not 0. Initial velocity is not 0. It is taken as u. U is the initial velocity. Acceleration due to gravity minus g. A is minus g. Now initial velocity is there, final velocity is there, but it is 0. we have a distance. We can apply distance velocity formula. If I apply v square minus u square is equal to 2as. The final velocity 0 minus u square is equals to, where a is minus g, minus 2g, s is h maximum. 2g h maximum. Both side minus minus get cancelled. Finally, we will get h maximum is equal to u square by 2g. This is the formula for maximum height. Maximum height is equals to u square by 2g, h maximum. And next parameter is time of descent. Time of descent, T suffix d. Time taken by a body to reach point of projection from the maximum height is nothing but time of descent. One thing you have to observe, time taken to reach maximum height, time of ascent, ascending order. This is my reference frame 0, ascending order, time of ascent. Now from the final maximum height to the ground, descending order, towards the ground, descending order, nothing but time of descent. Time taken by a body to reach point of projection, that is ground surface only, point of projection from h maximum, from the maximum height. So if you observe, this is the situation, the body again coming downward from maximum height to towards the ground, h maximum. Here we can observe the initial velocity is nothing but final velocity for the previous situation. It is the initial velocity of the body here is nothing but final velocity of the body. Time of descent. To derive it, I will use the formula s is equal to ut plus half at square, where s is h maximum, ut initial velocity of the body here is final velocity in the previous situation, final velocity 0, initial velocity. Now it is the freely falling condition, motion under free fall condition. So final initial velocity becomes 0. Initial velocity 0. So this term becomes 0. While it is coming downward, acceleration due to gravity plus g, half g t square. But I know what is h maximum. H maximum u square by 2g. I will use this term u square by 2g, that equal to gt square by 2. 2 get cancelled. Denominator both side 2 cancel. And if I move this g this side, we will get u square by g square, that equal to t square. Now apply root both side. What you will observe, 2 square root get cancelled. Finally t is equal to u by g, where t is t suffix d, time of descent. This is the formula for time of descent. If you observe one thing here, time of ascent u by g, time of descent u by g. So that we can observe, note, time of ascent is equals to time of descent. And next we will discuss last parameter, that is nothing but time of flight. Time of flight. Time of flight, t suffix f. The sum of time of plus ascent and time of descent is nothing but time of flight. You have to observe one thing, literal meaning of flight means if your body is in the air, if I throw any object from the ground surface, it is remains in the air. Now it is coming downward, after reaches maximum height it is coming downward, again it is in the air. So that how much time it will be in the air, that time is nothing but time of flight. So time of ascent, time taken to reach maximum height, still it is in the air. Time of descent, time taken to reach point of projection, it is in the air. That is the time t suffix a plus t suffix b, t suffix d, nothing but time of flight. Time of ascent plus time of descent, time of flight. T suffix f is equal to ta plus td, u by g plus u by g. If I take LCM, we will get 2u by g. Time of flight is equals to 2u by g. Now from the note point, t suffix a is equal to t suffix d, that is also can be written as tf by 2 also. Why? Because since time of flight is equal to 2u by g, 2 and 2 get cancelled, again you will get time of ascent or time of descent. Very important to understand.